Tech in 5.
Dive into Python with a fun game. Learn in just 5 minutes.
Welcome back, Python enthusiasts and aspiring game developers. In our previous video, we completed Gameplay Manager, setting the stage for our tic-tac-toe game to evolve into a truly intelligent challenge. Now, we're taking the final step in this exciting series, from the find immediate win to the defensive block opponent win, and the advanced tactics of the find best move algorithm. We're deep diving into the Python code that brings our tic-tac-toe AI to life. First, we're peeling back the layers of our tic-tac-toe AI to reveal two key strategies: find immediate win and block opponent win. These methods will make our AI both offensive and defensive. The find immediate win method is the AI's offensive strategy. It scans the board to find a move that would immediately secure a win for the AI. This method is based on the find player win function. In find player win, we iterate through all available moves. For each move, we temporarily place the player's symbol on the board and check if this results in a win. If it does, we've found our immediate winning move, and we return it. Importantly, we reset the board to its original state after each check to ensure no unintended changes are made. Conversely, the block opponent win method is the AI's defensive tactic. It uses the same logic as find immediate win, but aims to prevent the human player from winning. It does this by calculating the opponent's next potential winning move and blocking it. In our tic-tac-toe AI, one of the most sophisticated strategies is encapsulated in the find best move method, which employs the Minimax algorithm. This algorithm is a cornerstone of AI logic in two-player games for its ability to think ahead, making decisions by considering future implications of current moves. Minimax works by simulating the game several moves ahead, alternating between maximizing and minimizing the outcomes. In our context, maximizing means the AI is looking for a move that maximizes its chances of winning, while minimizing reflects the AI's strategy to minimize the player's chances of winning. The Minimax function is a recursive method that evaluates the board at each step of the simulation. It accepts three parameters: the current depth in the game tree, a Boolean is maximizing to determine if we are maximizing or minimizing at this step, and the player for whom we are calculating the move. The function first checks for terminal states: a win for the AI, return 1, a win for the opponent, return -1, or a draw, return 0. These are the base cases where the recursion stops. For each available move, the AI tries out the move by temporarily placing its symbol on the board. This simulates what would happen if the AI, or the player, made that move. This method then checks if that placement could result in an immediate win. If yes, the function immediately returns a score of 1 for a maximizing player, or -1 for a minimizing player. This quick check helps in identifying direct winning or losing moves. It then calls Minimax recursively to evaluate the board state resulting from this move. The depth parameter is incremented to reflect going one level deeper in the game tree, and next maximizing flips the perspective to the other player. This recursive call is where the Minimax algorithm explores future potential moves and their consequences. After the recursive call, the AI undoes the move to maintain the board state. It then updates the best score based on whether it is maximizing or minimizing. The function returns the best score achieved at that depth. In find best move method, we use this Minimax logic to evaluate all possible moves from the current board state. For each potential move, we calculate its Minimax score and select the move with the highest score as our best option. In case of multiple moves with the same score, we randomly pick one, adding an element of unpredictability. As we bring our tic-tac-toe game series to a close, we've journeyed across a vast landscape of programming and game development concepts, from the basics of setting up a tic-tac-toe game to implementing the state design pattern and exploring sophisticated AI strategies like Minimax. We've delved into a rich array of topics that blend theory with practical application. Thank you once again for joining us in this tic-tac-toe series. Until next time, happy coding!
Stay tuned for more videos on Tech in 5.